do I have a challenge for you? We're going to combine all those exponent rules that we've been learning about into one big giant problem here and to simplify. You'll notice that I have 3 variables on every single one of them and lots of rules going in. So let's take a look. Our first example we want to simplify is 15x to the 9th, y to the 10th, z to the negative 4th. So there's a negative exponent there. And then divided by 5, x to the 3rd, y to the 2nd, z to the 1st. Remember, there's a 1 there. All that's going to be raised to the 3rd power. So let's take a look. The first thing I want to do is simplify what's inside of the parentheses first. So I'm going to go ahead and say, go ahead and make this where I have something here raised to the 3rd power. Go ahead. And so I have 15 divided by 5. That's going to give me a 3. So remember, my coefficients still follow those rules. Now I'm going to start subtracting the exponents. So the exponents are the only thing that follow exponent rules because they're exponents. So coefficients still follow those regular coefficient rules that you've used to using. So I have 9 minus 3, which is going to give me x to the 6th. And then I have y, and I have 10 minus 2, which is going to give me 8. And then I have z, and I have negative 4 minus 1, which is going to give me a negative 5. Okay, that's kind of tricky because you want it to be, you want that to say positive. Now I'm going to go ahead and apply my raise to the 3rd power. So I'm going to have 3 to the 3rd power, x to the 6th to the 3rd power, y to the 8th to the 3rd power, and z to the negative 5th raised to the 3rd power. All of that there. Ooh, I wrote 2nd power. 3rd power there. So that's 3 times 3 times 3, which is 27. And then x to the 18th. Remember, when you take a power to a power, you're going to multiply. And then I have y to the 24th. So I have 8 to the times 3, which will give me my 24 there. And then I have z, and I have negative 5 times 3, which makes a negative 15. Still not quite done yet, because remember that you cannot be considered to be a simplified form if you have a negative exponent. So I need to move that 15 down to the denominator to make it positive. So I have 27, x to the 18th, y to the 24th, all divided by z to the 15th. And whew, now I'm done. Make a little bit better box around there. That's a long, lengthy process. So take it off piece by piece. You'll be good to go. Okay, so it looks like I'm going to have at least 3 rules going on here. If I don't have a negative exponent, I'm not quite sure. I'm going to divide, I'm going to raise a power to a power, and I'm going to multiply. So remember, the first thing I want to do is simplify what's inside of the parentheses first. So I'm going to go ahead and divide here. So I'm going to have 36 divided by 4, so divide coefficients. Now I'm going to start subtracting my exponents. So I'm going to have x to the 10 minus 5, which is going to be 5. And then y, 14 minus 7, which is 7. And then z to the 8 minus 2, which is going to be 6. Whew, no negatives. And then I'm going to multiply that by 2, x to the 5th, y to the 4th, z, all raised to the 3rd power. Now, remember, order of operations say you have to take care of exponents before you can take care of multiplication. So I need to take 2x to the 5th, y to the 4th, z to the 3rd power first. So I'm going to end up with 9x to the 5th, y to the 7th, z to the 6th. So I just carried that straight down. Now I'm going to take my 2 to the 3rd power, so that's going to be 8. So 2 times 2 times 2. And then I have x to the 15th, because I do 5 times 3. And then I have y to the 12th, 4 times 3. And then I have z to the 3rd, because I have a 1 right there, 1 times 3. Now I can multiply, which means I'm going to multiply the coefficients and then add those exponents. So multiply the coefficients. So I have 9. I'm going to go ahead and separate it out. So I have 9 times 8 times x to the 5th, x to the 15th, y to the 7th, y to the 12th, z to the 6th, z to the 3rd. All of those together. Okay, now I'll go through and just multiply out. So I end up with 72 x to the 20, because you're going to add those two together, y to the 19, because I'm going to add 7 and 12 together, and then z to the 9th, because I'm going to add 6 and 3 together. And that is your simplified form. Again, pretty lengthy. And I'm going to tell you, most of the problems you're going to see are going to be like this because they want to jam pack as many exponent rules as they can in one problem there. All right, so this one, not nearly as involved. It's just straight multiplication, but you do notice, hopefully, that there are some negative exponents there. So remember, when I multiply, I'm going to add exponents. So, but first I have to multiply the coefficients out front. Don't forget about that. So I do 4, so I'm going to do this. 6 times 4 times x to the negative 3rd, x to the 4th, y to the 5th, y to the 6th, z to the negative 4th, z to the negative 6th. Okay, so now that's a negative 4 there. So 6 times negative 4 is a negative 24. And then I have x, and I have a negative 3 plus 4. That makes a 1. So I can write it or not. It doesn't matter. Then I have a y, and I have 5 plus 6, which is going to make 11. And then I have a negative 4 plus negative 6, which is going to be z to the negative 10th. Now, I do have a negative exponent. Remember that a negative coefficient, just fine. Negative exponent, bad. All right? So I have negative 24, x, y to the 11th. They all stay up in the numerator because they're already all positive. And then z to the 10th has to go down to the denominator to become positive. All right, so basically, to simplify these lengthy expressions, you should take them to, just piece by piece. Still follow PEMDAS. Okay, so parentheses, exponents, then multiplication and division there. And rules for exponents. So those are listed on your formula chart, but remember, they don't give you the rules for those coefficients and make it kind of tricky. And remember that the mathematical processes are for the coefficients. So if you're supposed to divide, you're going to divide the coefficients. If you're supposed to multiply, you're going to multiply the coefficients. If you're supposed to take something to a power, you're going to take that coefficient to that power. All right? So that's what we have here. Again, just kind of unlayering all those rules and putting them all together now with one big simplification. Just piece by piece, make sure there's no negative exponents, make sure there's no fractional exponents, and make sure you're following those exponent rules. You got this.